In this video, we're going to do some more dilution problems. Let's go to our next example in the handout. What volume of a 6.0 mole per liter sodium hydroxide solution is required to produce 850 mils of a 0.100 mole per liter solution? So at first glance, this question's a little bit scary, but you'll notice that we start off with this concentrated solution of sodium hydroxide. And we want to make a more dilute solution. We want to make this 0.100 mole per liter solution. We want to make 850 mils of it. So what we want to do is we want to take some of this stock solution over here, this concentrated stuff, and then add water to it. So we want to figure out how much of this, volume-wise, we need to make this recipe, to make this 850 mils of 0.100 mole per liter solution. So in other words, what do we have? Well, we have the initial concentration. We have our stock solution. We have 6.0 moles per liter. That's the concentrated one. We know what our final solution is going to be. We know that we want our second concentration to be 0.100 moles per liter. So much more dilute. We've added quite a bit of water there. And we know we want, how much of that? We want 850 mils or 0.85 liters of that final solution. So we basically want to figure out how much of the dilute, how much of the concentrated, the stock, do I need to make this solution. So we can write our dilution equation down. C1 V1 is equal to C2 V2. And we can rearrange to get V1. Divide both sides by C1 or send C1 to the other side and you get V1 is equal to C2 V2 over C1. And so we can plug this in. So let's go ahead and do that as our third step. V1 is equal to C2 V2 over C1. And we get 0.100 moles per liter multiplied by V2, which is 0.85 liters, over the C1, which is 6.0 moles per liter. Delete the moles per liter, and you're left with liters. And so we have 0.1 times 0.85 divided by 6. And we get 0.014166666 liters. You could also write this in terms of milliliters. So you could say times 1,000, 14.16666667 milliliters, or to the proper number of sig figs, which is 2, 14 milliliters. So we can say, therefore, 14 milliliters of the 6.0 molar NaOH solution is required. So what that essentially means is you took a concentrated stock solution. So if I were to just sketch that out a little bit, let's do it over here. So this is our, just going to draw it in a beaker. This is your 6.0 molar NaOH. You took 14 mils of it and put it in here in the volumetric flask. And then you added water so that you could reach about 850 mils. So your water level reaches 850 mils. So you roughly put in 14 mils of your stock solution and about 836 mils of water, roughly. So it is much more dilute than it was before. Because again, the total volume of the solution is 850. you started off with 14 mils from here. And so you must have added about 836 mils of water to get you your 850 mils altogether. And so that's the volume of stock solution you need in order to dilute it to that volume, the final volume, to get that final solution of 0.100 moles per liter. Let's try one more problem out over here. What would the concentration in moles per liter of a solution made by adding 200 mils of water to 50 mils of a 5.0 mole per liter solution of potassium chloride be? So, okay, this seems a bit confusing at first. We want to find, it says, the concentration in moles per liter of a solution made by adding 200 mils of water to 50 mils of 5.0 mole per liter solution. So let's start with what we have, or what we know for sure. Our solution is potassium chloride, and we know its concentration is, its starting concentration is 5.0 moles per liter. And we had a volume of 50 mils, or if you do 50 divided by 1,000, you get 0.05 liters. Now, we want to know what will the new concentration be if to this 50 mils, you've added 200 mils of water. So in other words, your volume was 50 and you added another 200 mils. So now your new volume is 200 mils plus 50 mils. We're assuming the volumes are additive here. That means that they add together. They don't always, because of different densities and reactions and space that they take up, but we're assuming that they do add up here to 250 mils. So that's our new volume. In other words, this is a question that's very similar to previous questions with finding C2. It's just that you had to figure out that your final volume was not 200, it was 250, because you're adding 200 mils of water to 50 mils of a solution that already exists. So it's 250. And you can just write it as 0.25 liters. So now we can write our C1 V1 is equal to C2 V2 and rearrange to get that C2 is equal to C1 V1 over V2. And that's going to be 5.0 moles per liter times our V1, which is 0.05 liters, over our V2, which is 0.25 liters. Cancel liters out, and you're left with mole per liters, which is what's expected because you want a concentration. So 0.05 times 5 divided by 0.25, and you get 1 mole per liter. And that makes sense when you think about it. You now have 5 times the volume. So in other words, you should be 5 times less concentrated than you were before, right? Because when you went from 50 mils to 250 mils, that's 5 times. That's 5 times more water, essentially. And so you're 5 times less concentrated or more dilute than you were before. And is that the correct number of sig figs? Yes, it looks like 1 sig fig is what we need. So therefore, the final concentration is approximately 1 mole per liter. So again, if you tried this problem yourself first, check your work as you watch the video, mark yourself as if you're giving yourself a test or a quiz, and look at the steps that are done. So did you write your known information? Did you find your final volume? Did you write the formula you want to use and do a proper rearrangement? Did you plug everything in and include your units as needed and show the cross out? Did you include your final answer with the units? And did you make it to the proper number of sig figs? So those are the things you want to look for. And did you write a therefore statement with that rounded version in there? And if you did all those things, then it means you're on the right track with these questions. In the next video, we'll do the last question on dilution.